Okay, looks like about everyone is logged in, so let's go ahead and get started. I would like to welcome you to today's webinar, Revit Structure Interface with Scia Engineer. My name is Dan Monahan, and I'm the Managing Director for Nemetschek Scia in North America. Nemetschek Scia is one of the world's leading developers of integrated structural design software. For over 15 years, I've been helping firms evaluate and successfully implement AEC technology. With me today, I have Dennis Menson, Senior Product Engineer at Nemetschek Scia. Dennis and his team develop and drive the interoperability technology for Scia Engineer, and he's going to walk you through the various ways you could plug analysis and design into your Revit workflows. For some of you, Nemetschek may be a new brand, so I just have one slide on the company. You may be surprised to know that Nemetschek is one of the world's largest AEC software developers, with more than 300,000 users in over 142 different countries. We develop a large portfolio of software for the architecture, engineering, and construction industries. Our design-oriented brands include softwares like Allplan and Archicad, two of the world's most popular BIM applications, Vectorworks, a line of elegant 2D, 3D design software that has gone on to become the best-selling CAD program on the Macintosh and one of the leading design programs on Windows, and Cinema 4D, an award-winning animation and rendering application used in Hollywood and TV for special effects and used to create high-end photorealistic client presentations. In addition, Nemetschek offers a wide range of engineering and construction technologies, and the software we want to introduce to you today is Scia Engineer. Scia is part of a new breed of integrated 3D structural design programs, and while it may be new to you, it's not new software. It has a long development history, over 35 years, and as you'll see, it's a very proven solution that offers some very nice benefits for firms that are looking to migrate to or improve their 3D workflows. So, who uses Scia? Well, most of our customers are consulting engineering firms working on interesting projects in steel and concrete. In addition, you'll find Scia in engineering departments in larger industrial firms like Siemens or Fluor or Alstom Energy. And they work on all different types of projects, which is another advantage of Scia. It's a very flexible design program. While most of our customers are working in the building space, either buildings that involve architects or buildings that don't, we also have a large number of customers that are working on infrastructure projects, environmental projects, and energy-related projects. In addition, we have some very specific technology for the design of scaffolding structures, precast concrete manufacturers, and pre-engineered metal buildings. Here are some examples of what our clients are doing with Scia. Residential projects, typically higher-end homes done in steel or concrete, or multifamily residential like this example in cold form steel. Hospital and health science projects. I picked this project because it illustrates Scia Engineer's BIM workflow benefits. In this project, Gifford worked up the structural model in Revit Structures and used Scia's Revit Structure link to check and optimize the architect's design. We'll demonstrate this workflow a little later on in our presentation. Institutional design. This is another common project type like the student center being constructed in steel and concrete. This is an interesting project. It was designed by Sana, a Japanese architectural firm. It was one of the projects that the jury highlighted as an example of great architecture when awarding them the 2010 Pritzker Prize. The structure is made up of these thin concrete shells that parallel one another throughout the project but don't necessarily rest on the ground plane. In this project, Scia Engineer was used both for nonlinear and dynamic analysis and was used to analyze the construction staging and to simulate the removal of the formworks. It also illustrates one of Scia's key advantages, which is this ability to efficiently model these types of unusual shapes. Scia is also used for the design of both low-rise and high-rise buildings. In both of these projects, B6 Engineering in Dubai used Scia and the ETABS link to carry out third-party independent checks and to optimize the original ETABS design. And for structures like these and others that contain a lot of repetition, Scia has some very nice modeling tools that make the modeling of these structures very fast and efficient. But where Scia excels is when you have a project whose geometry or structural systems are a little unusual. This is why you'll find Scia Engineer being used by firms that work with higher-end architects like Zaha Hadid or Daniel Libeskind. This is an example of one of Libeskind's projects in Poland. And that work on specialty structures like this stadium in steel. Scia can also handle membrane structures, as well as timber structures. This idea of integrating multi-material design in one program is another central concept in Scia Engineer that we'll talk about a little later on. I picked this project because of the size and the complexity of the model. This is the new Confluence Museum being constructed in Lyon, France. One of the compliments we got from the design team was how well Scia handled the model. Despite its size, they didn't take a huge performance hit. They could still fly around in rendered views, and zooming and panning and screen redraws were still very fast. Then, on the other side of the design spectrum, Scia is used for more industrial projects like warehouses or manufacturing facilities, like this new Procter & Gamble plant being built in Saudi Arabia, or this limestone crushing line. Transportation and infrastructure is another industry where you'll find many Scia clients working, and at all different scales, from large projects like these to more pedestrian projects like this bicycle parking facility nicknamed the Apple. In this project, the engineer used Scia's XML export and Excel link to create a parametric study that allowed for easy design iteration and optimization. Scia is also used to design all kinds of bridges. Here we have a smaller bridge designed in steel and concrete. We can also handle larger bridges in steel and larger bridges in concrete and bridges with cables. And for bridges and buildings, Scia can help with the analysis during the construction staging. This is something that's missing from some general purpose finite element packages. Energy is another sector where many companies are using Scia. This is the next generation warehouse for the storage of spent nuclear fuel. Here, the structural modeling was relatively straightforward, but as you can imagine, the loading and the analysis were very rigorous. On this project, the engineer had to deal with special seismic loads, aircraft impact and explosion loads, as well as perform a detailed study of the soil structure interaction. And these are foundations going in for a new offshore wind farm being constructed by GeoSeas in the Irish Sea. In addition, Scia is used for many environmental projects like dams, wastewater treatment plants, locks, and other hydro projects. Lastly, we work with a number of companies that design large temporary structures for lifting, maintenance, and entertainment. Scia is used in the entertainment industry to design these types of temporary structures for outdoor exhibits and stage design. Well, that gives you a good idea of who we are. Now, before we jump into today's demo, for those of you who are new to Scia, I just want to quickly review the 4 key benefits that Scia Engineer can offer. First is fast and efficient modeling. For any engineer looking to work in 3D, modeling is the first key requirement. Scia Engineer offers freeform modeling and parametric modeling that allow users to quickly sketch up any design. In addition, like Revit and Tekla, Scia Engineer can maintain a structural and analytical model in parallel, but unlike Revit and Tekla, Scia can run analysis in the same modeling environment. This offers some great advantages for engineers working in 3D. With Scia, we can start a project by importing a design model and then quickly deriving from it an analysis model, check the model, and then push back an optimized design for model coordination or documentation. Or with Scia, we can start with analysis. We can explore different design ideas, and then once the design is solidified, we could derive from it an accurate structural model in Scia Engineer that we can then share with others involved in the design and construction process. So in a Revit workflow, we can start with a design model coming in from an architect, or a structural model coming in from a draftsman or a technician, or we can start from an analytical model. We'll demonstrate the details of these different workflows later on in the webinar. The second key benefit to Scia Engineer is advanced multi-material design. Scia Engineer makes nonlinear analysis not only feasible, but cost-effective, and where we can, we'll try to centralize your design tasks into one multi-material environment. Next is automatic and coordinated documentation, to make the documentation process more efficient, but more importantly, to virtually eliminate any manual coordination errors. And lastly, interoperability and collaboration. We want to make it easy for you to share files with others involved in the design and construction process, whether they be upstream with architects or downstream with contractors or fabricators. Today's presentation is going to focus on this last bullet and how we make it easy to plug analysis and design into today's Revit workflows. Now, we recognize that there's not one program that can do everything, so we want to give our users the flexibility to plug Scia Engineer into as many different workflows as we can. To that end, if a program has an open API like Allplan, Revit Structures, Tekla Structures, Pro Steel, or ETABS, we can write to that. We can also link to programs via XML. For BIM and plant design, we have certified support for IFC, which gives us a vendor-neutral way to exchange models with any BIM-compliant software program. And we support common exchange standards like DXF, DWG, VRML, PDF, just to name a few. The idea is to make it easy for you to recycle designs created by others, no matter what program the designer is using, and then pass back optimized models for collaboration and detailing. This is a big benefit when it comes to interoperability and collaboration in Scia Engineer. In today's presentation, we're going to focus in on the interoperability with Revit structures using the Revit link available in Scia Engineer and IFC or OpenBIM. Both have advantages depending on your workflow, the type of projects you're working on, and where you are in the design process. Now, let's turn the presentation over to Dennis and take a look at these Revit Scia Engineer model exchanges in a little more detail. Dennis?
Thank you, Dan, for the introduction. Again, my name is Dennis Mense and I'm a product engineer at Nemetschek Scia. As a product manager, I am responsible for many of the BIM developments within the company. Today we are going to discuss the possibilities of exchanging models between Revit Structure and Scia Engineer. The Revit Structure interface is a plugin for Revit Structure that allows you to bidirectionally exchange models between Revit Structure and Scia Engineer. The direct connection between both software allows you to easily exchange data of multi-material projects for any geometry. All types of objects are supported, such as slabs, walls and shells, but also beams, columns and bracings. It is not limited to only the exchange of geometry. Also analytical data such as supports and loads are supported. Remember that you can choose whether to exchange the whole model or just a selection of your project. This way it supports all types of jobs that needs to be done. Let's look a bit closer how the Revit Structure interface works. It is based on three main principles, which are the exchange via the API, the exchange of analysis models, exchange of object information via mapping tables. The exchange via API means that the link is a direct connection between both software, by means of what we call a programmer's interface, that we can change and allows us to share the information. Before we go to the demo, I would like to discuss a few topics that gives you a better understanding about the software. First of all, you have to understand that Revit Structure and Scia Engineer support both structural model and the analytical model. It is important to know that the Revit Structure interface is solely based on the exchange of the analytical model. This means that modeling in Revit Structure can only be done if the project contains analytical objects. Here we see an example of a structural column in Revit Structure. If we would send this column to Scia Engineer, we can see it as an analytical object and it is ready for analysis. It is important to remember that although the software is different, the analytical model is what they have in common. The next important principle to understand how objects are handled in Revit Structure. Object modeling is done by families. Families are libraries with objects and it is common for customers to use families that are built to fit their workflow. But to be able to send data to Scia Engineer, the interface needs to understand what kind of object it is handling. To be more exact, what type of cross-section and material does the object contain. Because every family is unique, the interface allows you to define the relation between the cross-section and materials in Revit Structure and Scia Engineer. Here we see an example. In the Netherlands it is common to have a description which can be seen here. But since the description is not always exactly the same, the interface needs to know some relation to the object in Scia Engineer. In the mapping table you define such a relation. In this case this seems very logical, but if we look at the family name we see that this is a generic description, cannot be interpreted by the interface. Of course we provide you with a default set of mapping rules which supports all default families provided by Autodesk. On a last note I want to show the common workflow. In most cases we start modeling in Revit Structure and send the design to Scia Engineer for analysis. In Scia Engineer we can check the design according to the building codes and update the design accordingly. Cross-sections can be changed or objects can be moved. The model can be sent to Revit Structure and the design is automatically updated. The bidirectional exchange can be done unlimited amount of times until the design is finished. Enough about these theories. Let's see how it is done in practice. Here we can see Revit structure. After the installation of the Revit structure plugin, you have an add-in available in the tab at the top. Here we can see the result of the installation. You now have the export and import functionality available for your use. First, I would like to discuss very briefly are the options. You have some export and import settings, some filters about what or you do not want to exchange. But more importantly, always set the correct standard when doing the exchange. For instance, when I use a British project, always set it to British standard. Why? Mainly because setting the standard also determines which type of mapping table is being used. Also, always set the correct Scia Engineer version. If I want to send, for in this case, to Scia Engineer 11 version 1223, I set it to this version. It defines the path and also makes sure that when opening Scia Engineer, it opens the correct version. Next are the preferences to whether or not you want to launch Scia Engineer. In this case, I've set it to no. When set to yes, it automatically opens Scia Engineer. When I set it to no, it prompts and asks me to save to a certain file, in this case the R2S format. The R2S format is used then to open the file in Scia Engineer and have the Revit structure project opened and used for analysis. Next is the user mapping. These rules determine the behavior, what will happen when a material or cross-section is unknown. In this case, I will not automatically set the material or cross-section to unknown when sending the project. I will now always be asked to determine or define myself what kind of material or cross-section is, and it will be saved to the user table then. Then from the user table, going to discuss the mapping tables. First of all, preferred tables. This is a list of all the available mapping tables. In this case, I determine what has the highest priority. For instance, when I have an object which is unknown, it will browse through any of the mapping tables and look for the appropriate cross-section. It will first start in the user table and then the Netherlands columns and then move down to the beams until it has found the appropriate setting. Some cross-sections can be found in both, for instance, the Netherlands or British tables. So in that case, if it starts with the Netherlands columns and then it will probably use that one. There are some mapping rules and defining about the Revit family pad, but I will not go into much detail about that. Important is for most users are the user tables. What are the user table? The user table is the defined mapping for cross-sections which are really commonly used by the user, or families that are unique for the user. So as I discussed previously, many of the users have used different type of families which are unknown to us as a vendor. We cannot predefine the relations for you, so you have to do it yourself. These relations can be made in the user table. If you want to have some general information, you can always install the plugin for free and review, for instance, the demo, review the help, or have some more information about the version of the plugin. So let's start using the bidirectional link. First, I would like to show you about the analysis model. As you can see here, we have objects in Revit structure that all have analytical lines. If you want to check it, whether the project contains analytical objects, you can easily switch on temporarily display only analytical model categories. As you can see now here, we can see really clearly the analytical lines that are in the object. As I discussed before, these are the objects we will exchange to Scia Engineer. So let us start now. I will go to the options and do some settings. For instance, I will do it a check according to Eurocode. This is the correct version, but I want to start Scia Engineer directly. So I will click to yes. For all the other settings are fine for me at the moment. So I will just click to export Scia Engineer and the objects are exported to Scia Engineer. As you can see here, this is an overview of all the objects that will be exported. So it will first browse through all the objects and then see what will be exported. For instance, as you can see here, the load case is not exported. Here we have a message saying that a cross-section is not found. So because of the missing rule for the mapping, this question is asked. So I can now myself define what rule will be used. So for instance, for the HEA 120A, I will create a beam, Netherlands beam, and then define it as HEA 120. I will click OK. This rule is now added to the user table. So next time when I do this project, this question is not asked and it is automatically corrected mapped. We will now wait for the project to be finished. It's being prepared and exported, and Scia Engineer will open when it's finished with the appropriate analytical model. The project is now loaded in Scia Engineer. We wait until the analytical model appears. As you can see, the analytical model is exactly the same as it is in Scia Engineer. Important is to note that this is a multi-material project, in this case steel and concrete, and even openings are added to the project. The project is almost ready for analysis. What we can do now is add some supports. And next, add a load. Besides self-weight, we can have a roof load. So let us add some loading to the roof. So now we have a project that is ready for analysis. We click on the analysis button. And the project is being calculated. We will briefly wait for the analysis to be done. Okay. We can now see the results. For instance, because of the roof load, or you can see, for instance, the stresses on the roof, etc. Let's say you needed to make some changes for the design because of the analysis. We can now select some columns and change, for instance, the cross-section from 500 to 450. The changes can be reflected in the Revit structure model. If we would open Revit structure, we can now easily import the Scia Engineer model in Revit structure. So we just click import and it will read the Scia Engineer file and updates the Revit file automatically. As you can see now, instead of 500, the cross-section is 450. So the changes are reflected in the model. You can do all sorts of changes, from changing cross-section, moving columns, and even adding extra objects to the project. This was so far the demo for Revit Structure interface with Scia Engineer. Here we see some examples that are done by our customers. Especially the last project is very interesting. The Spartak Moscow Stadium by Acom was a complicated roof structure which was curved in both directions. In Revit Structure it was impossible to do the design. Because of the design capabilities of Scia Engineer, it was decided to do the design in Scia Engineer and send the model to Revit Structure for documentation. As you can see, it is not always necessary to start in Revit Structure. The link fully supports bidirectional exchange. There are some key points of interest I would like to discuss. The use of Revit Structure interface has some implications on the workflow. When using the interface, it needs to be clear who is responsible for what model. In general, the draftsman is using Revit Structure for the design. At the same time, he is creating the analysis model which is used for analysis Scia Engineer. He is responsible for the structural model, not the analysis model. The engineer always needs to check if the analysis model is correct. If this is not done, issues during exchange can arise. Also, always make sure that your mapping is correct. Because of these implications, I would like to show you an alternative. We call it OpenBIM. OpenBIM is a universal approach to the collaborative design, realization and operation of buildings based upon open standards and workflows. The OpenBIM is an initiative of Building Smart and several leading software vendors using the OpenBIM Building Smart data model. Because of OpenBIM is based on the use of reference models, there is a more clear boundary between the responsibilities. As a user, the main advantages are that you can work with any software that best fits the type of work that needs to be done without risking the exclusion from a certain BIM project. Users can maintain full control over software upgrades independently from their peers in different projects they participate. The workflow integration results in reduced coordination errors if you compare it to sheer file compatibility of different software tools. Because of open standards, BIM data can be used for the entire life cycle of buildings, including construction and operation. To show you the difference between the direct interface and the OpenBIM workflow, I will give you a short demo on this workflow. Here we can see Revit Structure. I start with creating an IFC file and import that file in Scia Engineer. I choose to import the members as solids. Why do I do this? Because we import a structural model, we want to decide as an engineer what we want to analyze. This is what we call using the Revit Structure project as a reference model. When I click OK, the import starts. We now wait until the import is ready. Here you can see the result, a 3D model. Since the model is not ready for analysis, we need to prepare the analysis model. This is what distinct OpenBIM from the direct connection. The engineer is now responsible for the analysis model, while with the direct connection it needs to be done by the Revit modeler. I will isolate on stories to get a better overview of the structure. I now select the members I want to analyze and isolate them for better access. Since solid objects cannot be analyzed, they need to be converted to analytical objects. This can be done by what we call the member recognizer. Member recognizer is part of the BIM toolbox, a set of tools specifically designed for BIM workflows. As you might see here, the analysis model is not yet correct. Since a difference in nature of the structural and analytical model, it is possible analytical lines do not connect after recognition. This is something we need to correct. There are two options, manual or automatically. Today I will show you only manual because the structure is simple enough to show you. With the help of trim and extend, I correct the analysis model. To further complete the model, I will add supports and loads. After this is done, the project is ready for analysis. So we now start calculating and wait for the results. We can now view the results. Here we see, for instance, the internal forces of the beam of load case number 2. If we switch to the rest of the objects back on, we can clearly see the difference of the analysis and structural model. Again, the reference workflow is different, but it also allows you to easily check the whole part of the project without any of the responsibility issues. Of course, we can adjust the model accordingly, the results and the building codes, but instead of sending it back to IFC, back to Revit Structure directly, we use tools such as Solibri Model Checker to analyze changes that have been made. According to the results in Solibri Model Checker, we report to the modeler and he will correct the Revit structure model with the changes made by the engineer. Although this might seem extra work, it makes it more clear who is responsible for what, and it highly reduces the possibility of errors. Thank you for your attention.